Hey guys, in today's video we're going to look at the GeeksForGeeks question of the day. Count possible ways to construct buildings. So in this question there is a road passing through a city where there are n plots on both the sides of the road. So each side has n plots and the plots are arranged in a straight line on either side of the road. And we have to determine the total number of ways we can construct between in these slots such that no two buildings are adjacent to each other. Specifically, buildings on opposite sides of the road cannot be adjacent. So we have to check on one side of the road if no two buildings are adjacent to each other. The same should repeat on the other side. So this is the visual representation. There are 3 open plots on the left side and 3 open plots on the right side because n is equal to 3. And finally we have to return an answer. Answer is an integer. We have to return the integer with mod 10 power 9 plus 7 because the answer can be very large. We are shortening it using modulus operator. Now let's take a look at these 2 examples and see how we can form the logic. So imagine this is the road. And if n is equal to 1, there is one plot on every side. So this is first side and this is the second side. Now let's calculate only for one side. We have a plot there and there are 2 ways. We can leave this plot empty or we can build a house here. So this is one way and this is the second way. So total there are 2 ways. And on the second side too, this is the same option 2. On one side there are 2. The second side also there are 2 and the total number of possibilities will be 2 into 2, 4. So 4 is the expected output. Now let's try for n equal to 3. So there are 3 empty plots on one side of the road. Let's calculate for one side. So number of ways is initially 0. So we can leave all the plots empty. We can build one house here. We can build one house here. We can build one house here. And we can build one house on the ends, leaving the middle plot empty. Because we have to make no two adjacent plots are buildings. So these are the 5 ways in which we can fill on one side. So on second side also there will be 5 ways. So 5 ways here and 5 ways here. So total there will be 25 ways because 5 into 5 is equal to 25. So 25 is the output. Our technique is that we have to first calculate for one side only. So let's look at the combination from n equal to 1 to n equal to 6 for example and see if we can find any pattern. You will automatically solve this question once you find the pattern. Let's start with n equal to 1 and this can be empty or it can have a house. So number of ways is equal to 2. So for one side, if n equal to 1, there are 2 ways. Now let's do for n equal to 2. Now if n is equal to 2, there are 2 slots. Both can be empty. There can be one house here. There can be one house here. And these are 3 combinations. So total number of ways is equal to 3 when n is equal to 2. Now let's do for n equal to 3. Now if n is equal to 3, all 3 can be empty. We can place a house on every slot, one house on every slot, and we can place one house on the ends. So total there are 5 ways. So when n equal to 3, there are 5 ways. Now let's try for n equal to 4. So all 4 can be empty. Place one house on each. Place one house with one plot gap on the previous 4 combinations. There can be 2 plots gap because they said at least 1 plot gap should be there. Here there is 2 plots gap. So this is also valid combination. And here you can see repeated combinations. So you can remove 1. And here you can see again repeated. So you can remove 1. So total there are 8 ways. So when n equal to 4, there are 8 ways. Now let's try for when n equal to 5. When n equal to 5, all 5 can be empty. Place a house on each. And in the previous 4 combinations, place a house with one house gap. Now place a last house here. And now we can place 2 houses on the ends. And now we can place one house here. So total there will be 13 combinations when n equal to 5. And similarly when n is equal to 6, there will be 21 combinations. So here if you can observe the number of ways, it is forming a pattern 2, 3, 5, 8, 13, 21 and so on. So this is the Fibonacci series, right? But here in the series it starts from 2, but generally Fibonacci starts from 0, 1. That is the only difference. We start our DP array with this. So we have to implement the Fibonacci series question code using dynamic programming so that we can form this table. So generally Fibonacci series is the sum of previous 2 elements. So 2 is formed by 1 and 1. So this will add as dp of 0 and dp of 1. So these values are going to be from dp of 2 to dp of n plus 1. So this is being formed by 5 is formed by 2 plus 1. 8 is formed by the sum of these 2. 13 is formed by sum of these 2. 21 is formed by sum of these 2. So these are the steps. We create DP array of size n plus 1. We set the first element and the second element as 1s. And using a for loop, we will iterate from 2 to n. So iterate from 2 to n using for loop. starting from 2 and ending at n. N should include, n is inclusive. And then calculate value using the sum of previous two values, that is n plus n minus 1, and that will give you for one side. This is important. After getting that value, you have to multiply it one side into one side, will give you the total number of ways you can form for two sides. And finally, you have to mod it and print the output. Now let's implement these steps in a Java program. Coming to the function given to us, this is the function name and this is the input n given. We have to return an integer representing the total number of ways we can construct buildings, such that no two buildings are adjacent to each other. So first let's declare this, which is 10 power 9 plus 7. So I'm going to name it Fibonacci, which is of the size n plus 1. And now we know the Fibonacci series, it starts from 1, 1. So I'm going to assign it as the first two elements. So first element, a 0th index, is going to be 1. And similarly, the first index at index 1 is also going to be 1. Now we start filling the Fibonacci array from index positions 2. So we run a while loop starting from 0 until n. Now we know how to form the Fibonacci number. It will be the sum of the previous two numbers, I minus 1 plus I minus 2. We will store it at I. So Fibonacci of I, Fibonacci of I minus 1 plus I minus 2. And now this for loop will fill that array. And now we find the answer by summing the last two elements inside the Fibonacci number, that is Fibonacci of n plus Fibonacci of n minus 1. Number of ways on one side. I'm going to name it one side ways. N minus 1. And now this should multiply into 2 times because, so this value gives you the number of ways you can place buildings on one side. We have to do the same for the second side because there are two sides of the road. So I'm going to name it two side ways and multiply this twice. Equal to one side ways into one side ways. And now finally I will return this. This is a long variable, but we are expecting an integer variable as the output. So let's typecast it into int. And now we have to mod the values. So let's mod this value before adding it into this value. And let's mod this too. And now after adding those two numbers, let's mod the total too, because that might also give you a large number. And now again here, before adding and storing it inside this, let's mod it, mod the entire sum. We have to mod this too. So two side ways is equal to two side ways mod. Now we finished applying mod to all the big values which we were expecting. Now let's try to run the code. So this is long. We're getting the expected output. Let's submit the code. And the problem is successfully accepted. So the time complexity of this approach is O of n because we need n iterations to fill the array. And the space complexity is also O of n because we are using a 1D array to form the output. That's it guys. Thank you for watching and I'll see you in the next video.